The rules for solving inequalities are very similar to the rules for solving equations. Sometimes you'll be working through the steps of solving an inequality and the variable seems to magically disappear. Well, the first thing you do is not panic. It's one of two situations. If the variable disappears, simply look at what you're left with and decide, are you left with a true statement or a false statement? So if the variable disappears as you're solving an inequality and you're left with a statement that is always true, such as 5 is greater than 3, 5 is always going to be greater than 3. If it's always true, that means there are infinite solutions. And what that really means is that you could basically put any value in for x and it would make a true statement. So the inequality would be true for all values of the variable. So once again, you're working through the steps of solving an inequality, the variable disappears, you didn't do anything wrong. Just decide, are you left with a true statement or a false statement? If it's a true statement, there are infinite solutions. X, or the variable you're solving for, could basically be anything. Second situation is if the variable disappears and you're left with a statement that is never true, such as 8 is less than 2. 8 is never going to be less than 2. That's a false statement. So if the variable disappears, you're left with a statement that is never true. That means there is no solution. There is no value you can put in for x or the variable you're solving for and have it make a true statement. So if the variable disappears, it's one of these two things. If you're left with a statement that is always true, there are infinite solutions. The variable could be anything. If you're left with a statement that is never true, there is no solution. There's no value you can put in for the variable to make it a true statement. So as you can probably guess, in this inequality, the variable is going to disappear. The question is the inequality always, sometimes, or never true? Well, we covered always true and we covered never true, but what about sometimes? Well, sometimes is going to be if you get a solution to an inequality such as x is greater than 4 or x is less than negative 5. Those are examples of it sometimes being true. So if we go to solve this for x, use distributive property with the negative 2, makes that negative 6x minus 2 on the left, and on the right is greater than negative 6x plus 7. Now your next step would probably be to get the x's to one side. So if you go to combine the x's, in other words, add 6x to both sides, we would end up with negative 2 is greater than 7. The variable disappeared. You don't panic. Just look at that again. Is it true or false? Is negative 2 greater than 7? Negative 2 is not greater than 7. It's never going to be greater than 7. So to answer this question, it is never true. But what that really means is that there is no solution. There's no value you can put in for x to make that a true statement. Next inequality, 5 times the quantity 2x minus 3 minus 7x is less than or equal to 3x plus 8. So we have a lot to do here. We have a distributive property, then we're going to need to combine like terms on the left side. So distributive property with the 5. Take 5 times 2x, that is 10x, and 5 times negative 3, that would be negative 15. Still have minus 7x, and then on the right side, nothing changes there. It's 3x plus 8. Put the less than or equal to sign still there. On the left side, it's a good idea to combine the like terms on one side before you go moving items around. So combine 10x and negative 7x, that would be 3x. So it'd be 3x minus 15 is less than or equal to 3x plus 8. Now your next step would likely be to get the x's together on one side. So we're going to subtract 3x from each side. And when you do that, the variable disappears. We have negative 15 is less than or equal to 8. So the variable disappeared. Don't panic. Just decide, is that true or false? Is negative 15 less than or equal to 8? When negative 15 is less than 8, it doesn't have to be both. It can't be both. It's not less than and equal to. It's less than or equal to. So negative 15 is less than 8. That's a statement that is always true. And since that's always true, to answer this question, is it sometimes or always sometimes or never true? It is always true, but to answer or to talk about this up here, if it's always true, that means there are infinite solutions. So you could basically put any value in for x and it would make a true statement. So if the variable disappears and you're left with a statement that is never true, that means there is no solution. There's no value you can put in for x to make that a true statement. And if the variable disappears and you're left with a statement that is always true, that means there are infinite solutions. X, in this case, could basically be anything. You may have two inequalities put together using the word and or the word or. It's called a compound inequality. And the word and or the word or mean two different things. So if someone says he's tall and smart, that means he's both of those things. He's tall and he's smart. But if someone says he's tall or smart, that means he's one or the other. He's either tall or smart. So the word and or the word or mean two different things. And means he's both of those things, or means he's one or the other. To solve a compound inequality involving the word and, we're going to start with a compound inequality involving the word and. Find all the values of the variable that make both inequalities true. So here we have 7 is less than 2x plus 1, and 3x is less than or equal to 18. That is a compound inequality involving the word and. So we're going to find all the values for x that make both of these inequalities true. Just like when you say he's tall and smart, it means he's both of those things. So to solve these, you're going to take each one of these individually and solve for x. In this first one, subtract 1 from each side. You would have 6 is less than 2x. And then divide each side by 2, you end up with 3 is less than x. Or you could say x is greater than 3. It's the same thing if you flip that around. In the second inequality, divide each side by 3, you get x is less than or equal to 6. So there you have 3 is less than x and x is less than or equal to 6. But really, you could put those together into one string. You could say 3 is less than x, which is less than or equal to 6. So putting both of these together into one string, 3 is less than x, which is less than or equal to 6. Now graphically, what that will look like is if you start graphing 3 is less than x, it means you would put an open circle on 3 and the arrow would start going to the right because 3 is less than x. It's to the left of x. And for the x is less than or equal to 6, you would put a closed circle on 6 and the arrow would start going to the left because the value of x is to the left of 6, but it could also be 6. So once again, an open circle on 3, the arrow starts going to the right, and a closed circle on 6, the arrow starts going to the left. So the value of x lies between 3 and 6, but it could also be 6. Now what does that mean about the big picture of this compound inequality? Remember, when you're solving a compound inequality involving the word and, you're finding all the values of the variable that make both inequalities true. So x between 3 and 6, also including 6, any of those values, if you put them into either inequality, it will make a true statement. And you could check that by taking any of those numbers on that line, including 6, put those into both inequalities, it will make a true statement in both inequalities. Just like when you say he's tall and smart, he's both of those things. So the value of x, any value of x on this line or on this closed circle, put into both inequalities would make a true statement. We're going to solve this compound inequality involving the word or this time. Last time we had one involving the word and. For example, if he's tall and smart, he's both of those things. All of those solutions worked back into both inequalities. But this one has the word or. So if you say he's tall or smart, he's either tall or he's smart. He's one or the other. So these solutions that we get here for y will work in one or the other, not both inequalities. So if you have 7 plus y is greater than or equal to 6, or 8 plus y is less than 3, just take each one of these and solve each one individually. And that first one will subtract 7 from each side. And the second inequality, subtract 8 from each side. So in that first one, you get y is greater than or equal to negative 1. And the second one, y is less than negative 5. So the value of y is greater than or equal to negative 1, or the value of y is less than negative 5. Now to graph these, you put a closed circle on negative 1 with the arrow going to the right, and an open circle on negative 5 with the arrow going to the left. So y is greater than or equal to negative 1. Again, that's a closed circle on negative 1 with the arrow going to the right. And y is less than negative 5. It's an open circle on negative 5 with the arrow going to the left. So what does this mean? The value of y is greater than or equal to negative 1, or the value of y is less than negative 5. So what that means to this compound inequality is these solutions found on this graph where y is greater than or equal to negative 1 only work in this first part of this inequality. The solutions on this graph where y is less than -5 only work in this inequality. So if you take these solutions for y is greater than or equal to -1 and substitute it into this, it's going to be a false statement. And if you take these solutions and substitute it into this, it'll be a false statement as well. These solutions only work in this inequality, and these solutions only work in this inequality. Remember, he's tall or smart. He's one or the other. He's either tall or he's smart. In comparison to he's tall and smart means he's both of those things. So an or inequality, what you'll see there is you'll see a graph that splits off in opposite directions. An and inequality, when you're talking about compound inequalities, an and inequality will come together from both directions. So when you say he's tall and smart, he's both of those things. He's all of those things together. But when you say he's tall or smart, he's one or the other. So the graph of an or inequality will split off in opposite directions. An and inequality will be a graph coming together. We're going to find the solution set to each of these inequalities and then also graph those. We have an and inequality on the left and an or inequality on the right. Now know the difference graphically what these will look like. For an and inequality, you'll have a graph that comes together. For an or inequality, you'll have a graph that splits apart. So we'll take each one of these in this and inequality and solve each one. So this 5 is less than or equal to 3x minus 1. Add 1 to each side to get 6 is less than or equal to 3x. And the 2x is less than 12. Divide each side by 2. We have x is less than 6. For 6 is less than or equal to 3x, divide each side by 3. Get 2 is less than or equal to x. And x is less than 6. That's already done. So you could say that 2 is less than or equal to x and x is less than 6. If you wanted to write that together as one string, you would write it as 2 is less than or equal to x, which is less than or equal to 6. Graphing this, 2 is less than or equal to x, you would put a closed circle on 2, and the arrow would start going to the right because the value of 2 is less than or equal to x. So closed circle on 2 means it could be 2, and the arrow going to the right means that 2 is less than the x. For the x is less than 6, you would put an open circle on 6 with the arrow going to the left. So x is any number between 2 and 6, but it could also be 2 because of that closed circle. So x is between 2 and 6, including 2. The solutions on this graph from 2 is less than or equal to x and x is less than 6, any of those solutions will work in both inequalities. If you say he's tall and smart, he's both of those things. He's tall and he's smart. All those things together, all of these solutions work in both of these inequalities. Now for the or inequality, take each one, solve each one individually, and this first one will subtract 3 from each side. You have 7z is greater than 8. In the second inequality, add 1 to both sides. 4z is less than -12. Back to that first inequality, divide each side by 7. You're going to get a fraction there. Z is greater than 8/7, or you might say 1/17. And for the second inequality, divide each side by 4. Don't change your sign. You're dividing by a positive. Yes, you are dividing a negative, but you're dividing by a positive. You only change the signs when you're multiplying or dividing by a negative. So that stays as z is less than -3. Now graphing this, you're going to see a graph that splits off in opposite directions. For z is greater than 8/7, that would be an open circle on 8/7, which is 1 1/7, and the arrow would start going to the right. For z is less than -3, you're going to see an open circle on -3, and the arrow starts going to the left. So all values of z are greater than 8/7 or less than -3. Remember, these solutions only work in one inequality or the other. Like when you say he's tall or smart, he's one or the other. He is not both of those things like this over here. So these solutions where z is greater than 8/7 or 1 1/7 only work in this first part of the inequality. These solutions, z is less than -3, only work in the second part of the inequality. So if you took these solutions for z is greater than 8/7 and put them into the second part of the inequality, you get a false statement. If you put these into the first inequality, you would get a false statement as well. But if you substitute them back into the respective inequalities, you would get true statements. So again, an and inequality will come together as you see here. An or inequality will split apart. Again, think of tall and smart versus tall or smart, the difference between those two. Here you have a compound inequality written together as one string and not separated by the word and or the word or. If it's written together as one string, it's actually an and inequality. So -6 is less than 2x minus 4, which is less than 12. There are two ways that you can solve this for x. I'm going to show you two ways. The first way is how I would do it, how I recommend doing it. It takes the least amount of steps. Least amount of steps prevents mistakes. More steps, the more chance of making a mistake. So, and then after I'm done with that, I'll show you another way, which I don't recommend, but it could work if you don't, I guess if you don't like the first way. So -6 is less than 2x minus 4, which is less than 12. You have three different areas here. You have a left, a middle, and a right. Remember, when you're solving for x, if you want to isolate the variable, you have to get everything away from it. Well, if you think of this as three different areas, a left, a middle, and a right, we need to move the 4 and we need to move the 2. So we're going to add 4 to start with to the left, the middle, and the right. So if you add 4 to the left, -6 plus 4 is -2. If you add 4 to the middle, the -4 and 4 will cancel. You're left with 2x. And if you add 4 to the right, 12 plus 4, that is 16. So still we have a left, a middle, and a right. We need to move the 2 now. So to move the 2, you have to treat all of these areas equally. So if you divide by 2, you have to divide the left, the middle, and the right all by 2. So if you divide the left, the middle, and the right by 2, you end up with -1 is less than x, which is less than 8. Now again, that's an and inequality. That means -1 is less than x, and x is less than 8. So that's the way I would solve that if I had to solve a compound inequality written together as one string. Here's another way. You could separate this. You could take this first part. -6 is less than 2x minus 4. Separate that from the second part. 2x minus 4 is less than 12. So when it's written together as one string, it is an and inequality. And if it's an and inequality, you can separate it into two separate inequalities. So on this first one, you're going to solve that for x, add 4, get -2 is less than 2x, and then divide each side by 2, you'd have -1 is less than x there. Second one, add 4 to both sides, you get 2x is less than 16, and we end up with x is less than 8. So -1 is less than x, and x is less than 8. I told you up here, that's what this means. That is an and inequality. -1 is less than x, and x is less than 8. So no matter which way you do it, you're still going to get the same answer. But you can see there's less steps in this first method than there is in the second method. Less steps means less chance of making a mistake.